Okay, so we have developed a very powerful tool to help us find slopes of tangent lines. Now this tool is so important that it has been given a name. Because, we're not going to go around and say, well, let's find the equation that represents the slopes of the tangent lines to this function. I mean, that's a lot to say. And so what we did, because this gets used so much and finding this equation is done so often, we called it the derivative. Let me go back to this little piece of paper here. You just can keep on writing in your notes though. And so let's look at the definition of the derivative of a function. So the derivative of a function f with respect to the variable x is the function f prime, so that's new notation. That's going to mean the derivative, whose value at x is, and what we write is we say f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay? And then over here we'll say provided the limit exists. Provided the limit exists. Alright, so there are cases, and we'll look at those later, but there are cases where this limit doesn't exist, and therefore you don't have a derivative at that point. Okay, so here's a new vocabulary. We have this concept of the derivative. Here's the actual definition of a derivative. Okay? And it's this limit that we have to evaluate it. The process of finding the derivative is called differentiation. So let's write that out. The process of finding the derivative is called differentiation. Okay, so there's another new word. Okay. And if f prime exists, we say that f is differentiable at x. Let me see if I can squeeze that in here. If f prime exists, we say that f is differentiable. So there's another new vocabulary word. Alright, so we have this derivative. We have what the definition of the derivative is. It's this limit. That is the actual definition. And then if you can take the process of finding a derivative is called differentiation. And if f exists, that means the function is differentiable. Alright. One more thing with this definition of the derivative, and it has to do with notation. So I'm going to use a little piece of paper down here. And And there are many ways to express a derivative with notation. So there are many different notations to express a derivative. Let's write that. There are many different notations to express a derivative. All right, so one we had up here, that was f prime of x. We could also have y prime. So if you start off with y, you could just say, here's the derivative, y prime. We also have dy dx. We could say df dx. You also might say the derivative with respect to x of the function f of x. Once in a great while, yeah, I don't see this too often, but if you go on in math, you might see this capital D with a little x, and that means to take the derivative with respect to x. And for historical purposes, we'll do a y with a little dot on it. Okay. So there are a lot of notations. A lot of that had to do with when calculus was developed. It was developed by two people simultaneously, basically. One was Newton, one was Leibniz. Newton used this dot. So I think the dot turned into primes over time. Leibniz used this dy dx. It's called differential notation. And they both survived, and a lot of times this is easier to write out, but we do use differential notation for certain cases because it's easier to work with. But anyways, as you go along, sometimes you see these notations and they all mean the same thing, taking the derivative. Okay, so this was a very big video that we just went over, and a big concept. We started with this idea of the tangent line problem. Before this video, if I asked you to find the slope of that tangent line, we had no way to do that. But then we went along and we created this idea of why don't we take secant lines, find the slope of the secant line, and then little by little, as we got this other point closer and closer to the original point, we created this limit. Again, we have to use a limit because you can't put in 0 for delta x. That doesn't work. But as long as we get infinitesimally close to x, that's okay. As delta x gets close to 0, that's what we want. And so we were able to go through a whole example of finding the equation of a tangent line using our new limit. And we decided to call this limit, well, not us, people in history decided that this was so important that we will give it a name, and it is called a derivative. And so there is the derivative. And now that we have the name derivative, we don't ever have to say, well, let's find the equation that represents the slope of the curve. That makes no sense. Actually, that might not even be technically correct. We can now say, let's find the derivative, and that is technically correct.